This is Mr. Anderson for Kellogg Community College, Math 130. Today we're going to be talking about section 10.1 in the statistics book to talk about scatterplots and correlation. Alrighty, let's get going here. So, what's a correlation? Well, a correlation is a method used to determine whether a linear relationship exists between two variables. For example, we can have two variables like the amount of homework that you do and your grade in the class. If you increase the amount of homework you do for the class, then that should have a linear relationship with your grade to the class. And we can see that among different people and different sets of data, and a lot of educators take this data at the end of their class to see if there is a correlation, and there usually is. What is regression? Well, the regression describes the nature of that relationship. So once you take all the data of all your students who did your homework and then compare their grades, then you can talk about the relationship being either positive, which means that your homework had a positive effect on their grade, or negative, which means that maybe that they did so much homework they weren't studying for the tests. As homework went up, grade went down. That would be a very interesting situation. I can't say that it's never happened before, but there's an example of positive and negative. Positive correlation is when you talk about as one goes up, the other goes up, and negative is as one goes up, the other goes down. So we're going to talk a little bit more about direct and inverse relationships coming up here. Now, the four purposes of looking at correlation and regression is to see, are the two variables linearly related? You're going to find out that sometimes they're very linearly related, sometimes they're loosely linearly related, or there's no correlation. Because we also want to find out, hey, they are related. Well, how strong are they related? And that's a pretty important thing. What kind of relationship is there? Is it pretty much a positive relationship or a negative relationship or no relationship? All right, and what predictions can be made? Once you make your prediction about the strength of the relationship, you can then extrapolate and go beyond it. For example, if I did 90% of my homework and got this grade, what if I did 100% of my homework? Would my grade be much higher? Or if I did half of the homework, would my grade be much lower? These predictions are very powerful, especially in business and in psychology and in the real world, where you can test medications, you can test sales, you can test quantities of an item versus the output that you want. So let's take a look at just some rough sketches about scatterplots. What I'm going to do is make just some fictitious data, but we need to kind of remind ourselves a couple things from the first chapter. This here is, whoops, I had it on the rectangle builder there. This here is the dependent variable. The y-axis is always the dependent variable. The y depends on the x-axis, which is the independent variable. The independent variable can change. Like, you can decide how much homework you're going to do. Are you going to do 100% of it or 0%? And your grade will depend on the homework. It's interesting. I am basically, first of all, just making up plots of data. So I'm just putting some dots, just on the screen here, and each dot would represent a person. A person who did a lot of homework would be expected to have a high grade. A person who didn't do a lot of homework would expect to have a low grade. So the question becomes, what kind of relationship is this? Well, for the most part, this group seems to be moving in this positive direction. So this is considered to be a positive correlation, and the strength of it is what we're going to do today on our graphing calculators. We are going to figure out how strong our relationship is. Now, obviously, the negative aspect would be, dots that kind of look like they're going down in a certain direction, and this would be a negative relationship, and this would also be possibly strong. And again, we have a pretty good idea of what the perfect strength and the perfect negative strength would be. But, when you start getting dots that don't actually line up, then you have a problem. Now, a perfectly strong positive graph would be dots that would be in a perfect line. That would be a perfect strength, and a perfect negative strength, would be the inverse relationship, would look like that. These never happen in real life. We don't ever see these straight lines that show up. So this is a positive correlation. This is a negative correlation. As I said before, this is a direct relationship. And the direct relationship means that as you do one thing, it directly affects the other in the same way. More homework, better grades. Now this is a negative correlation, or an inverse correlation, which means that as one goes up, the other goes down. Let's say the number of days I am absent from class goes up, my grade will fall down, which is important if you have a class that has an attendance grade. Okay, now here's a situation where you take all the pieces of data, all the students in your class, and you look at their homework, and this is what you see. You see some people who had high levels of homework with low, medium, and high grade output, and some people with low homework input had a high grade output up here. So this means no correlation. And this no correlation means that you're not going to have a strong line going up or down, or even flat. A flat line wouldn't really traverse through many or any of these dots very well. So this is an example of no correlation. Your data's all over the place. Now, the last part I want to do here is I actually want you to, instead of just randomly creating a scatter plot, what I want you to do is I want you to create a scatter plot using a set of data. And the homework from this section is going to be pretty much all that. You're going to be given an X value and a corresponding Y value. And I'm going to put context behind this picture here in just, well, at the turn of the page. I'll let you know what this is talking about. But without any context, I just want to see if you can plot these points. Now, the points are going to be on the X and on the Y, so you'll notice that this is a blank graph. So the first question is, well, what kind of criteria do I need for my scatter plots on the tests and on the homework? Well, the first thing you need to do is label your axes. And what's important about that is you'll notice that the axes, they are uniform in length, but they don't have to be the same size as the Y values. Notice that my X values are all double digits from 8.5 to 63, and the Y values go from 1.5 to 7. So there's no way we're going to make this the same length on either X and Y scale. So what we're going to do is we are going to figure out what should be my X minimum, X maximum, and the scale to go by. Now, for most scatter plots, you're going to start with 0 on my X and 0 on my Y. So I need to get through 63. To get through 63, from 0, my best value should go by is tens. Now I'm going to be a little lazy here, and I'm going to skip every other one, but really my scale is going by tens. 10, 20, 30, 40, 50, 60, all the way to 70, and it's nice to go a little bit beyond your data set. Now on the Y values, we go from 0 through 7, which is coincidental because I actually made this to go all the way up to 7. Now, what would have been nice is if I went up to 8, because it's kind of nice to go a little bit beyond your last data point so it doesn't appear in the corner of the screen or on the plot, and that will be evident later. Now, what I'd like you to do is to pause the YouTube video and plot the points. Now, if you're unsure how to plot the points, no need to pause the video. I'll show you right now. X is 8.5, so we go to 8.5 over on the X and 1.5 on the Y. So like in the game of Battleship, where you had a ship at maybe A3, this is a ship at 8.5 on the X and 1.5 on the Y, and that connects to make one dot. X is 13.4 and Y is 1.4, so there we go. And this is 19.1 and 2.8. Okay. And we've got 20.8, which is right here, and 2.1. So you're going to see these cluster of dots. And then 29 is almost to 30 and 3.9. So it looks like there's an upward trend, doesn't it? It looks like these dots are going up. Now at 63, I'm going to carefully draw a line all the way up to 7 And you kind of see I have kind of this positive, strong relationship here. But we're going to find out, starting on the second page, how strong that relationship is. Now, this is what I need for a scatter plot, but I really need some context. Now, the context comes in, and I didn't give this to you earlier, but this is going to be the number of cars in the thousands car rental companies actually have out on the lot. So this is, or cars in tens of thousands, excuse me. So this would be 85,000 cars, 134,000 cars, 191,000 cars, 208,000 cars, 290,000 cars, and 630,000 cars. Now, the Y is going to be our profit in billions, which means that this is $1.5 billion in profit, 1.4, 2.8, and all the way up to 7 billion. So the question becomes, how strong is the relationship between the number of cars I have out for available rental and the amount of profit that I have from doing that? And that's important. In business, you kind of want to say to yourself, if I put, well, 120 instead of 63, will I get 14? And what the process on our graphing calculator is going to do that for us. Now, you may want to have this written down because I'm going to be referring back to this picture, but I won't be flipping back to it. As you see when I click off my to move the screen, loop, it's gone. So I'm going to go and talk a little bit more before we get into this car company correlation here. I'm going to talk about what is a correlation coefficient and how we measure it. All right, a correlation coefficient, it measures the strength and direction of a linear relationship between two variables. And the best way to think of a correlation coefficient is a positive or negative percentage. For example, if you had a scatter plot of just random dots, your value would be 0, no correlation. Now, if you had a very strong correlation, then your correlation coefficient would be a very high percentages, 80%, 90%, 95%. So this is what we call a strong positive correlation. And if you had an inverse relationship where the more you do something, the worse it gets, you'd have a negative 90%, a negative 80%, a negative, and I know it's a little sloppy to call them percents, but it's really the way you can kind of think of it. We're almost to a perfect negative 100% inverse relationship. And so this is called a strong negative. So, the correlation coefficient is given with the letter R. We're going to find this on our graphing calculator, and it is also given with the, it looks like a P here. I'm kind of trying to make it a little bit look like the Greek letter here. The Greek letter rho, spelled R-H-O, is also used for the correlation coefficient. Now, there's a process of getting R by hand on page I'm surprised I missed that. Page 541. But we're going to get R to show up on the calculator. So here's what we've got to do. We have got to, and I'm going to get my calculator up and running here. Before we enter in this data, I want you to get your calculator and I want you to get it to a clean screen. So get it to a nice clean screen, clear it out, and I want you to then go click the second key, which is this button in the upper left-hand corner, and the 0, which brings up a catalog of formulas. Now what we're going to do is we're going to scroll down until we get to something called diagnostics on. And there it is, diagnostics on, and once we do this, we never have to kind of set this up again. So click enter once, and then one more to confirm it, and you have now turned on the calculator's ability to compute the variable R. The correlation coefficient R. Alright, so let's now take some time and type this 63, this is the car data that you just plotted on the scatter plot. Plot this into your calculator. Click on Stat, and then click on the Enter key, and you'll notice that I've already typed mine into list 1 and list 2. I did this so you wouldn't have to just watch me clunk, clunk in the data here. So what I'm going to do is now switch, move this calculator down, and actually, you know what? I'm going to talk through the I'm not going to move this down just yet. I'm going to talk to the linear regression shortcut, and then I'm going to write down the steps afterwards. So once this is typed in, pause the video, type this in, and move your fingers with me so you'll get the muscle memory here. So up to this point, what we've done is we've turned our diagnostics on, we've clicked Stat Enter, and we've typed in this data. Okay, now the data, which is right here, is now into our X and Y. The top is always going to be our X, the bottom is always going to be the Y, and we are now going to do the linear regression shortcut. That linear regression shortcut is hitting the Stat key, clicking the right arrow to go to the calculator, and then we either hit the number 8 or scroll down to linear regression A plus BX. Now you'll notice that option 4 is the same, but statisticians use this format, not the slope format, for the start and the rate of, in this case, the rate of change, x, and that will be explained further in the next video. But what we're doing here is once we click on 8, we can click on it one more time to verify it. You will see that the R value is given to us. And our R value is 0.981, or rounded 0.982, or 982 thousandths, which means that we have a 98% strong positive correlation between the number of cars that are available for rent and the amount of billions of dollars of revenue that they have. And this isn't 63 cars, it's 63,000 cars, because this is in tens of thousands of cars. Actually, wait a second here, is that right? 63 tens of thousands? 63 tens of thousands would be... Hold on. now I'm having a brain spasm here. 63 10,000s. So 1 10,000 is 10,000. This is 630,000 cars. I said it right on the previous page. All right, so let's put the calculator away and let's write down some of this stuff here. So we have them in our notes. All right. So therefore, to turn on, gotta click on the right thing here. To turn on the diagnostics, it's going to be hitting the second key. Crap! Sorry. Second key. And then, oh, that looks good. 0, hitting the 0 key. And then you're going to scroll down using the down arrow key until you get to diagnostics on. And then you hit enter to confirm it. You got to hit enter twice. One to say, hey, I want the diagnostics on, and then one to process it. To enter the data, you hit the stat key, and then you hit the enter key. Okay, stat and enter. Then do the linear regression shortcut, which is stat right. That's the right arrow. Yeah, I'm sorry, my arrows are funky. 8. And enter. Stat right 8, enter. Okay. Now we're going to find R. Now we found R on the calculator, which is 0.982, which means that this is a positive, strong relationship. Yeah, positive, strong, raw. Now, since I'm not making you find R by hand, you are responsible for trying to get the scatter plot to show up on your calc. So here are some added steps I'm adding to the mix here. Okay, we've got to turn on our scatter plots. To turn on the scatter plots, you're going to go to the Y equals button. Bloop. Now the Y equals button has no equation in there, and hopefully all of these are not highlighted. But go up to the plot 1 and click enter. If you go to plot 1 and hit enter, this will turn on your dots, and you say, oh sweet, now I get to hit my graph. But unfortunately when you hit the graph is set up wrong. The dot, like you know that there's more than just that dot, so what you have to do is fix your window, step 5. So click on the window button and use the X min, X max, and X scale that we did on the previous page of the worksheet. 0, and we only, I think the X maximum here went up to 70, and the X scale should be 10. The Y minimum is 0. The y maximum, I know our y max was 7, but let's go to 8 just because it's nice to go a little bit beyond the highest x value. And we're going to go by ones. Never change the resolution. And there is your scatter plot. And you're going to need to see the scatter plot for the objective in the next video, so it's good to get your plots up on the screen. So to review, you went to y equals and turned this on. You then went to your window and fixed your window, and then went to your graph. Now I'm going to put the calculator away and write down the steps here in case you want to have a little hard copy of what I just talked about. To turn the scatter plots on, you're going to go to your y equals. And we're going to go up to where the plot 1 is and then hit enter to turn it on. The scatter plot is the default option. If you actually hit second y equals, you can kind of see all the options there, and you can make box and whisker plots, stem and leaf plots, and wait, can you make a stem and leaf plot? No, you can't. You can make a box and whisker plot, you can make a plot over time, and you can do all of those inside of your if you go to second y equals, you can see those. Now the window that we landed on was going from 0 through 70 by 10s, and y min was 0 through 8 by 1s.